my name. Okay.
Okay, so.
So I'm a presenter now.
You are the host.
Oh, the host.
Oh, let me.
Is the recording? I wanted it to. Okay.
Maybe I stopped the recording. Let me check if I can take.
The recording is available.
I think maybe you have to make me the host again. Sorry for that.
I think the recording is available. It's recording already.
It's in progress. Thank you.
Yeah, it's okay. Okay. Thank you, everyone. Thank you to those who are joining today. Today we'll be looking at PC assembly, personal computer assembly. What we said last time is that you guys are instructors. Please kindly mute your mic, please. Kindly mute your mic.
Come again.
Mute your mic. Mute your mic.
Okay, okay.
Okay. Thank you. So we'll be talking about PC assembly today, and in the last class we looked at the PC as a personal computer. We looked at the different components. We also talked about the south bridge, north bridge, looking at components that you have in the north and the south bridge and how they work together to as one unit. We also talked about the speed of the processor in terms of the number of transistors project in each of the CPU, which also determine the speed. So that's some of the things we discussed in the last class. And the assessment for chapter 1 is already activated for those of you who wish to take the assessment now. I think it's better you do the assessment as we go. There'll be no need for you to wait until you have so much assessment to do. So you can do them, and you can do them over and over again until you get it right. The essence of this course is for you to know it and be able to teach your students. So this chapter 2 will require a lot of hands-on. So it's expected that you already have workstations in your lab. You have a personal computer there. So we want to believe that after this class, you go back to those computers, open them up, and try to relate what we're going to discuss today with what you have in the system. And if you have questions in the next class, you're going to ask me those questions and I'll answer them before we move on. So today is we're looking at PC assembly, and then we'll look at the objectives. We'll look at how to build a computer, define general and fire safety standards. Should there's a fire outbreak, what should be done and what are the precautions to be taken? Connect the power supply, install motherboard components, install internal drives, install adapter cards, identify additional storage, connect computer components with appropriate cables. These are very sensitive, I must say, objectives that we must adhere to as instructors when we're teaching our students in the course of trying to demonstrate this. We said that all the lab procedures have to be observed to avoid harm in any form. So assembling the computer. There's a video when you're going through the main curriculum. You can watch the video that gives you a guide about the general fire safety precautions while working the computer. So since you're already enrolled into this class, you can play that video to see how to remove what is to turn off and unplug equipment, remove clutter from workspace, cover sharp edges, And these are actually videos you need to watch to be able to give you an insight into the precautions that ought to be taken. Okay, so I'll go straight to select the case and the fan. So the first thing here is that you open the computer case and connect the power supply. So here we're looking at when you have a complete computer system. You have the power pack. I showed us the power pack, a picture of the power pack in the last class for a desktop. And you have the computer motherboard. And then you have the computer case. And the computer motherboard, you already have the CPU. And then you have the hard drive and the DVD drive or the DVD, the compact disc. Now all those components ought to be assembled to give you one whole system unit. And so what we're saying here is that now you need to open this case, and when you open this case, the motherboard determines the type of case you can use. So usually, if you are probably acquiring a motherboard from the shop or from a computer shop, you need to look at the computer case. The computer case, or what we call the form factor. The form factor of the motherboard determines the computer case, which has to do with shape and size, like what we said that was on Tuesday. And so the size and shape must match. So you must get the right computer case that will match the right computer motherboard. And for size, a computer with many components will need more room for airflow to keep the system cool. So while doing the selection of a computer case, because you're looking at assembling, which of course, the first thing you need is a computer case, and then you talk about the motherboard. But remember, getting the motherboard also determines the computer case that you ought to use. And so what we're saying here is that the computer case, the computer motherboard must match with the computer case. So that means they have to be of the same form factor. Okay, and we say form factor has to do with size and shape of the device. And so you need airflow. So while considering the size, you also need to look at the ventilation to be sure that there's an inflow and outflow of air, because the motherboard will definitely overheat. This component, when you pass current and voltage through them, they overheat over time. So you need some kind of air to be able to balance this temperature. And so for a flow to keep the system cool. And then the power supply. You match the supply rating and connection type to the motherboard. Like we said in the last class, we said that you must use the right connector, the power connector. So we look at the ATX power pack and supply. We say, oh, this takes 20 volts, as the case may be. So you need to take the right cable, power cable, and plug to the right port. And we saw the different types of cables as they were. And the good thing about this is that if you're opening the computer case for the first time, with everything connected, you can easily tell which cable goes to a particular port because of the configuration, because of the form factor of the cable connector itself. And so you have to have that observation, and also let your student know why you're putting a particular cable, you're matching a particular cable to a particular port. Okay, so you must match the power supply rating connection type to the motherboard. Then you also look at the appearance. Remember, we're still looking at the computer case and the fan. You must look at what the appearance. There are many cases designed to choose from. So in the appearance, we're talking about how well positioned is that computer case, such that you're sure there could be in airflow, and then you're sure it gives you what you want exactly. So you don't just pick up a computer case, but rather you also consider its appearance. Status display. LEDs mounted outside of case. We're talking about the LED, we're talking about the light emitting diodes mounted outside the case to tell you if the system has power, when the hard drive is in use, and when the computer is in sleep, or hibernate mode. If you look at the computer case, usually most of the computer case gives that provision for the LEDs, such that you have different colors. Sometimes when you see the amber color, it tells you probably some kind of issue. So you need to also look at computer keys that provide that that function, or provide you that interface where the LEDs can be projected out, such that once they are working well, any of the companies are working well, you can really tell. When the hard drive is in use, you can tell because you see the light blinking, showing that probably you're trying to save something or some kind of transfer of data from the hard drive to probably a different device, or you actually opening up a new document from any of the partitioned drives. Okay, and so when a computer is in sleep, you can also tell. So what we're saying that all these are factors to be considered, or metrics to be considered when selecting a computer case and fan. The essence of the vent also, like we said earlier, is to ensure that you have some kind of air out of the system, because when you allow the system to build up heat over time, it makes the system unstable. We've seen situations in this part of Africa where we really have very high temperature sometimes. The weather can be so hot to the point that you even see the system shutting down or restarting. That tells you that it has gone beyond the temperature rate. A typical processor should be about 64 degrees centigrade at max. And once the CPU exceeds that temperature, you're bound to have the CPU restarting. And all is just for safety purposes. But that won't be good for the user. So in as much as possible, we're saying that when you're selecting the case, you make sure that you have cases that have good vents to be able to take in air and then blow out the hot air out of the system, and then recycling that whole process such that you have a functional system. And so you must tell your students the importance of this vent, how useful it is to the system. So they must know this, and then you also let them know that in the course of using their laptops at home, they shouldn't use it on a surface like on a foam or thereabout, that all those vents will be closed, and then before you know, the system will overheat. And that alone can actually lead to high component failure rates, because most of those components that are inside the computer motherboard have a particular mean temperature they operate with. So once the board gets overheated, definitely you're sure to have failure rate high among the components. So, and that will actually reduce the lifespan of the computer. So the student must know this and then be able to work with you on that. Okay, so the factors to consider when choosing a case fan is that the case size. So larger case often require larger fans, because smaller fans cannot create enough airflow. So that has to be considered. The speed, the fan speed. Remember, looking at the computer motherboard, from the picture we saw last time, that you have two fans. You have one fan that is seated on the CPU, and you have one fan by the side of the computer case. Now, larger fans can spin more slowly than smaller fans, which reduces fan noise, of course. So you need to look at the speed. And the need for this is that if you have more air coming from the fan, it creates a better cooling effect on the CPU. Number of components. So multiple components in the computer create additional heat that we know, which requires more fans and larger fans or faster fans. So considering the number of components, we need more fans, or we need large fans or faster fans to help reduce the heating effect. Okay, so physical environment. The case fans must be able to disperse enough heat to keep the interior of the case cool. So you need to look at the physical environment. You also need to look at the location where the position where you actually are. using the system. So all these have to be considered. Number of mounting places available. So different cases have different numbers of mounting places for fans, so that they can be easy airflow. Location of mounting places available. So you have different cases have different locations for mounting fans. And then electrical connections. Some case fans are connected directly to the motherboard, okay? And while others are connected directly to the power supply. So the power supply also have its own. So what we're saying is that these must be considered in the course of your selection. You must be sure that you have a fan on your power. Your power pack must have a fan. Your motherboard must have a fan that is directly connected on it. Those elements or factors are not, or like I said, those components are not there, then I think you have to reconsider that particular primary procurement if you're going to do that, so that you already know the implications. So these are the importance of getting the right computer case and fan. The essence, in summary, what we're saying here is that all this is to see how to control the temperature of the computer system. And with that, you'll be able to maintain better performance, because definitely the higher the heat, the lower the efficiency of the system. So more heat in the system, efficiency will drop. And of course, when efficiency drops, the performance of the system will also drop. So that is the implication. Okay. So factors to consider when choosing a power supply. Type of a motherboard. So the power supply must be compatible with the motherboard. So this is also, now we're looking at power supply, because we need to get the right motherboard with the right power supply. I was telling you sometimes that if you look at the power pack for desktops, we have a switch behind it that you can actually switch between 110, 220 volts SPP for some systems. And then some systems are already customized for a particular region. And so as you're procuring it, definitely deserve with the kind of power system you run in your country. So what we're saying here in essence is that the computer motherboard also determines the kind of power that it must take. So you must use the right power supply. This is not just for desktops, but for laptops. You don't just pick any power pack, power adapter from anywhere, and just because you can actually plug it into your laptop and you're sure you can plug it in. That is not the case. What we're saying is that the power adapter or the power supply from that pack must be the right requirement for the system. For instance, the system that is supposed to be 19 DC volts meant to take a 2 ampere, that's 2 ampere current. You can imagine you now using 18 DC volts with probably less than 2 amperes. By the time you multiply the two, you discover that when you multiply current by voltage, it gives you what we call power. And so you'll be hearing power supply, power supply. So power as an entity is equal to your current times the voltage. And so if your power pack, for instance, is 18.5 and your current is probably 1.2, 1.3 case maybe, and originally the power adapter for that laptop, actually the default or the one that came from the manufacturer is probably 19 DC volts, maybe 2 and maybe 3.5 amperes. But then you multiply it, you can see here that there's going to be a sharp difference between the two. And so if you use that kind of power adapter on your laptop, of course, sometimes it works, but in the long run, it will end up destroying the system, because the amount of power that will be going into the system might be less. And so the component on the computer motherboard will have to overwork itself to be able to make up for the required amount of power to be able to drive all the devices. So we're saying that this is very, very critical and important, in as much as you need to also let your students know the implications. So required voltage, wattage, So add the wattage for each component. If the wattage is not listed on a component, calculate it by multiplying its voltage and amperage. If the component requires different levels of wattage, use the higher requirement. So you could see here that they're saying required wattage. Remember, I just said something here that power is equal to current times voltage. So they're telling us here that imagine that you want to use a particular wattage, and probably the device gives you a range that, oh, you could use from 18 volts up to 19.5 volts, you know, and that is the range given to you in that specification. So, but in this case, what we're saying is that it's better you use the higher requirement than using the less one. So if I have a range of maybe 18 to 19.5, then it's better I use 19.5 than using the 18. That's what this is saying here. And then number of components. Make sure the power supply provides enough wattage to support the number, the types of components, plus another 25% at minimum. So you see, this should be at minimum 25%, such that at every point in time there's adequate power that will be able to drive those components. Remember, those components you have on your motherboard can't be effective without power. That is why we need to understand the kind of power that goes into the system. We need to do some calculations to tell if that's the right amount. And so in your lab, you need to get what we call a multimeter. A multimeter helps you take readings in current and voltage, and at the same time take power reading, so that you can be able to tell what the output power is. The reason why I'm saying this is that in parts of Africa, sometimes we have issues with low voltage, as the case may be. And when we find ourselves in such situation, you have to be careful before you power on the desktops, computers, or use your laptops, because the current that might be, the voltage that might be coming into the system might be under delivered. So you need to use your multimeter to check and then see if what is coming out is enough to be able to power the system. So you don't just put the system at risk by using low voltage. So all we're saying here is that you need to make sure you check the voltage rating, you check the power rating and the ampage at every point in time to be sure that it actually meets standard. So type of component, make sure the power supply provides the right types of power connectors. So type of case, make sure the power supply can be mounted in the desired case. So now you're getting a power supply. Make sure the power supply can actually go into the case. So if you buy a computer case and your power pack cannot fit in, then it's as well as not needed. I mean, it's not actually serving its purpose. So what we're saying here is you need to get the right form factor. The power supply must match with the computer case so that you can be able to insert it inside the computer case. So in your lab, you're going to do this yourself. Also, when your students are on ground, you make sure that in the lab you install a power supply in the computer case. Show them how you take the power pack, and then you bring it into the computer case, and then for them to see, and then you to screw it to the computer case. So the student must be able to demonstrate this. Okay, excuse me. So there's a video. The good thing about it is that there's a video you're going to watch as you read the material, and all the video will do is to give you the right orient the CPU to the CPU slot, press the CPU into the CPU slot. I've watched this video; it's quite fantastic. It gives you exact true life scenario. So you're going to do this, watch the video, and also go to the lab, practice it yourself first as an instructor before you call up the student to come and see what you're doing. The essence of this is when you're doing this because you're assembling the system. So we're saying that you must match the right orientation of the CPU with the slot. So the CPU is the central processing unit which must sit on the slot. So that slot actually, you must make sure you have the right orientation. The orient the CPU. such that it must clip with that particular slot. So you have to be very careful, and you don't need to force it. It's quite very simple to actually place. So you must turn it around until make sure you get the best position for it, and then push it in. Press the CPU into the CPU slot. Lock the CPU. It has a lock. I'm going to show you in the subsequent slide. And then the lock helps to hold the CPU. Apply thermal paste to the CPU. There's a thermal compound or substance on top of the CPU before you stick the heat sink on it. That thermal substance is it actually helps to absorb heat from the CPU to the heat sink. So the heat sink sits on the CPU. So the essence of that thermal paste is so that it will quickly, the very fast rate, absorb the heat from CPU to the heat sink, and then the fan on the heat sink will blow the heat away. Then install the heat sink and then secure the heat sink. The heat sink has a guide, so you put the guide. And then once that is done, you watch the next video on to install the RAM. Now, this video shows how to open the RAM slot and look at the how to orient the RAM chip to the motherboard slot. It also lower the RAM chip into the slot and press down firmly to lock the RAM. Now, this is a procedure of how you take the RAM. You look at the orientation of the RAM, and then take the RAM straight to the slot, and then you press it down, and then once you press it, you get that sound to tell you. I mean, there's this clip, kind of a clip sound to show you that the RAM is actually connected to the slot, and then you press it down to lock the chip, the RAM chip itself. Now, this is a procedure for the RAM installation, which you can actually watch. So it's a straightforward process, so that even when the RAM is faulty, you can remove it and then plug it back. Now, you're doing this because you are assembling the system, the computer system. And so these are the procedures, because most of the other components are already embedded on the motherboard. So the only thing you might be adding up on the motherboard is the CPU, the heatsink, the fan, and then the RAM in most cases, and probably when you're adding new adapter cards or new features. Apart from these things I've just mentioned, the other things actually are there, except they are faulty, and then you're removing them to put them back. So once you can get a procedure of putting the motherboard in the right position, you get the procedure for putting in the CPU. In most cases, you don't need to remove the CPU, except you're probably working on the board. But in this case, we're saying when you're buying a computer case and you're buying a motherboard, you have to also consider buying a CPU in some cases, and then see how you can actually insert it. You must get a RAM as well. Make sure the RAM is compatible with the board. And so once you have put the CPU in the right position of the CPU slot, you've put the RAM in the right position of the RAM slot. The next thing here is to install the motherboard. Now you're picking up the motherboard, and there's a video also that demonstrates how to install the motherboard, which makes it beautiful. I've also watched the video straight to the point. It aligns the motherboard in the correct direction. So the motherboard now is as a circuit board. You pick it up, look at the right direction, and then place it there. Locate the standoffs. The standoffs are actually some support at the bottom of the computer case. So when you fit the motherboard, those the standoffs create that whole fitting such that you can now use screw to tighten it. So align the input-output plate to the back of the computer case. Make sure your input-output has your VGA port, your USB HDMI, your PS2 port. All those ports must come out, must also come out on the computer case so that you can be able to plug any of the peripheral devices. So you lower the motherboard into the place, install the screws into the standoff, and then you're good to go. So this is a typical picture of a motherboard. This is not far-fetched from what you already know. You can see here, this is the sitting of the CPU. So you need to orient the CPU such that you sit properly. So you must show your students, before you do that, you press this hook. I mean, there's a hook that holds down the CPU. So before you bring out the CPU, you release this hook and take it up. And then when you remove the CPU and then probably you want to put a new one, you also do the same. While it's up there, you now insert the CPU here. So we also mentioned RAM. This is the RAM slot. So you can see RAM slot. And then this is the expansion slot. Expansion slot. And then here you have the ATX supply port here. This is where you have a 20-pin slot for your power supply to the motherboard. So as we go on, we'll look at the other components. But for now, you can see here that there's different slots where you plug in your RAM, your other features are available. So this is how the typical computer board is. And then so you could see from this angle here, we mentioned input output, but in the case of selecting the right computer case, you must also look to show that all your input output are actually outside the case here, so that you can, when you want to plug your USB, you can plug it, your HDMI, you can plug your flash drive. So this is where you have the input output. Okay. So remember, we also talked about the north and the south bridge. So you can now agree here that this is the south bridge where you have your input output. So the video, I would advise that we watch the video to help us understand it better. So we select the CPU and the cooling, all in the Intel socket. So we have sockets for Intel and AMD. Remember, you have two major, most. Hello?
Yes, we are here.
Okay, I see. I guess somebody sending me a message. At the end of the chapter, you can, there will be questions, so you can be putting down your question. Or do you want to be asking questions as I go?
No, sorry, it was me telling them that questions will be at the end of the session.
Okay, thank you very much. Okay, so we have two type of sockets. We have the Intel socket and the AMD socket. The reason we're saying this is because you have Intel processor and you have the AMD processor, and you must look at it that their orientation is not the same. And so here it's been specified such that when it's an AMD socket, you must match it to the right AMD processor. And so also the cooling fan. So all that to come in. So you can see socket type, the heat sink or fan type must match. So invariably, all these factors have to be certified for you to be able to have an effective system assembly. So here is to install the motherboard component. We're looking at the RAM here also. So new RAM may be needed when an application locks up or the computer displays frequent error messages to determine if the problem is the RAM. Execute the RAM test in the BIOS. The speed of the new RAM must be supported by the chipset. So here you're looking about selecting RAM and putting in RAM on the motherboard. But in some cases, you need to upgrade RAM. So what we're looking at is the assembling. So we're talking about system assembling here. Is you getting the right RAM that will fit into the right motherboard. And once you get that, if for any reason the RAM is not working well, like what you're seeing here, you go to the BIOS settings. Most of the systems, when they are booting up, you can interrupt the booting process by pressing F2. Some systems, it has different function. All you just need to do is you power on the system, and then you can see that from the setup file, and then be able to tell whether you need to press this function or the other function. So whatever is the case, what we're saying here is that if the RAM is not working well and begins to display some errors or whatever, we're saying that there's a need for you to carry out a test, and this test can be carried out through the BIOS. I mean, you can actually interrupt the booting process, like I said, using F2, most of the systems, and then carry out the test procedures. Not only for RAM, you can do tests for your hard drive if you're not too sure if your hard drive is working well or not. Once the test is completed, then you can now check to see if you can get a new RAM. So memory also will be categorized into unbuffered or buffered type of memory. So when we say when it's unbuffered, this is a regular memory for computers. So the computers read data directly from the memory bank, making it faster than buffered memory. So the buffered memory now is that it has to what open up something like we use buffered memory for servers, oftentimes for big servers machines. So here, like I said earlier, the computer reads data directly from the memory bank because it's unbuffered, and it's actually faster than buffered memory. Reason because it's taking it directly. It is not something that is queued up and waiting in a temporary memory before you use. So buffered memory, specialized memory for servers and high-end workstations that use a large amount of RAM. So these have a control chip built into the module that assists the memory controller in managing large quantities of RAM. So in this case, if you look at the way computer servers are built, they are quite robust, big enough for you to increase the memory of the RAM and all of that. So we're saying that actually gives you room for it to be buffered to be reason because you expect it to have a lot of data coming in. And that does not mean it's not fast enough, but it's not as fast as when it's unbuffered. Because when it's unbuffered, it means that it's fetching the information almost immediately. It's not something that is kept over time before it's fetched and then decode or execute. So this is like picking up information as they are readily available. So that is for the unbuffered, and for the buffered, it means that it has to have that built-in module that will assist your memory for a built-in module to help manage large quantities of RAM. And for you to, if you look at it, servers are actually where we have very high quantities of RAM. Okay, so here you will install the motherboard in the computer. As in the lab, you will install the CPU, the heatsink, the fan, the RAM modules on the motherboard. You will then install the motherboard into the computer case. So I'm giving us this like an assignment, and that by tomorrow, I want to believe we have access to systems, computers. If you do, then we can try out this in the lab, and then you give me some feedback in the next class if you're able to do that. That will help you to actually familiarize yourself with what we're saying here. And so, because you're going to demonstrate this before the students, that will help them in the future when they are doing troubleshooting as well. Okay. So that's chapter 2, telling us that we must assemble the computer motherboard. We talked about this already. So, so the video to install the drive. So the next thing here is that if you recall, we talked about the computer case. We went further to talk about the power supply, how to look at the different components, and then we talked about how to install each of those CPU, RAM, and then we move further from that to looking at the computer motherboard itself with your RAM, and then checking for errors and all of that, the different types of RAM types. But here we're talking about drives. When you talk about the drive, you're talking about the hard drive. So how do you install the hard drive? So here there's a video that demonstrates how to install the hard drive, which you have to watch. And then when you're watching that, you also see that the position of the hard drive is such that the lines with the drive by opening it. So the power and the interface connector should be facing out towards the motherboard. Usually, like I said, it also depends on the computer keys. The computer keys will also give you a guide on how the hard drive can be fixed. But usually, in most computer keys for desktops, they have a bay, more or less a slot where those hard drives fit. So, but then the hard drive has two distinct ports. one for the power and the other one for data. So you get the right cable that will go into the serving for the power and the one for the data. And usually in these modern systems, you actually SATA cable for power, SATA power cable, and SATA data cable that will go into the computer. That's into the hard drive. So you insert the hard drive into the drive bay, like I said, so that the screw holds the drive line up with the screw holes in the case. So there's a screw hole in the case, and that of the drive, which once you screw it, it will hold it firm. And then you secure the hard drive to the case using the proper screws. So please, we also need to take note of this. Ensure that you use the right drive for the right screw, so that when you're doing this, you don't have issue of messing up the system. So we just have to look at making sure that we use the right lab equipment for carrying out assembling, troubleshooting, as the case may be. Okay, so there's a video here to show us how to install a drive. I want us to watch that video and see how that works. The video demonstrates about the drive, and then from the front of the case, choose the drive bay that you want to hold the drive. Remove the faceplate from that bay if necessary. There's a faceplate usually in some of these computer case. You can remove it if necessary. If you think that will help your hard drive to suit well, you can do that. And then all you just need to do is you break that slip, like a case covering the hard drive. So also for the computer from the disk drive and the other components that actually will sit in that bay. So you can actually remove them, but if it doesn't obstruct it, you can leave it that way. The reason is because once you do that, you can be able to have access to the hard drive directly. So insert the optical drive into the drive bay so that the optical drive screw holes line with the screw holes in the case, like we say, and then secure the optical of that drive such that you don't have issue putting it wrongly, because that could actually damage it. So what we're saying here in essence is that all these have to be properly placed in the computer case. Okay, so this is a picture of a hard drive. Most of us have seen this. So you can see here that you have this port here, and you have this here for the data, and this is for the power. This is a 500 gigabyte drive. Okay, and then this is the optical drive. The optical drive for you to help you to read information on your CD or your DVD or case maybe. Okay, and this is how you install it. So if you look at this picture here, this is a screw hole on the HDD. So you can see the hard drive going into the bay. So here we put the screw here, and then once you screw that nut, it will actually hold down the hard drive so that it will be firm. You know, and then you do the same thing at both ends. Don't put it in such a way that it will start falling off. No, it has to be very, very firm. Once you do that, you do the same thing for the optical drive as well, and the other components that ought to get into the bay. So this whole space you're seeing here, we call the bay, and then you can see that there are vents also that takes in air, like we were talking about earlier. So this is a typical computer case, and this is a hard drive inside the computer case. So we already have these in our various desktops, in our offices, in our labs, and all we just need to do is to open up the computer case and demonstrate this to our students. You should be able to use your screwdriver to screw it to bring them out and then put them back and all of that. So we do this a lot for the children in school so that they can be able to learn how these things are actually assembled. And that's a very good way. It helps to boost the confidence of your of your pupils or students in school, because once they get to know that they can assemble this, I mean, it's like wow, for the first time they're able to do that. So you allow them to do this practice over and over. And once they get familiar with it, when there's a problem with the system, it also helps with the process. It help in the troubleshooting process, because the student will be able to tell where the fault is coming from. Since he or she already has been taught how to assemble the system. So install the optical drive. So you see the procedure for installing the optical drive. You can put it directly like this, but in some computer case, you don't put it directly like this. You have to put it from inside. Now you can see what where I'm pointing my cursor here. That is the lead covering your drive. Like in this case, now it has been removed. That's why you are able to push in the optical drive. So we're saying that it can be removed, if you think it's going to obstruct your drive. So you can see this computer case. You can see how robust this computer case. Yeah, you can see the vent allowing air to go in. You can see the form factor of the computer case. This also, like I said, also determine the kind of motherboard that will be placed in there. Okay. So in the lab, you install the hard disk just like I just showed us, and see how it is being placed. So it's also important that we read up or watch the video on how to install adapter card. Remember, I showed us the expansion slot in motherboard. That's a computer motherboard. The expansion slot is where you now actually put in the adapter card. The adapter card is meant to provide you additional features. For instance, if maybe you just have 2 USB ports and the 2 USB ports are bad, you can't just write off the system. You can go get an adapter card that provides more USB ports. And all you need to do is to insert it in the expansion slot. And then here you go, you have as many USB ports as possible. You might have HDMI ports. So it gives room for new devices to be added to the computer. Okay, so we need to demonstrate that to our students, let them know the usefulness of the expansion slot. So still on the adapter card, you can have the adapter card designed for specific tasks and extra functionality to the computer. So you could have different types for graphics, for sound, for storage controller, for input output, for NIC, which is the network interface card, for capture. Now, these are some of the areas that you can get adapter cards for. So you can get adapter cards that can help provide all these functionalities. So you looking at that expansion slot is just telling you that rest assured that once you need any of these features, all you just need to do is to buy the card. You open the computer case, you plug in there, and then you start using it immediately. So other factors for adapter card, consider is that before purchasing an adapter card, consider the following question: what are the user's current and future needs? Is there an open and compatible expansion slot available? What are the possible configuration options? So we're saying before you get that adapter card, you need to look at this whole question. You need to answer this question yourself before you get an adapter card. What is the current? What are the current user current and future needs? You're asking this because you want to be sure that the adapter card you're going to get will cater for this. And then, is there an open and compatible expansion slot available? You also need to check that out. If you're sure that it's compatible, if there's a compatible port there that will go with the device, that you have to consider. And what are the possible configuration options? Are there possible configuration options? For some adapter cards that come in what we call the form of a RAID that require you to configure them, sure, you have to look at those options. So what we're saying invariably is that all these have to be looked into before you get an adapter card. So don't just get an adapter card. be sure that the compatibility is there, be sure that the right slot for that adapter card adapter card is available, and then there are possible configuration options you also need to look at. Sure, all these are factors to be considered because adapter card will serve different purposes. Like we said, we look at the picture here. This is capture card for taking up new videos or real life event. This is your NIC, which is network interface card. You can see this is a different adapter card. This is your input output card. You can see this input output card. It could be HDMI or USB. This is storage controller. So this is just for storage purposes. And this is sound card. So you can see. So if my sound is not working well, I just go buy a sound card and I'm good to go. And then this is a graphic card. So what we're saying is that if all these cards are not the same, it means that if you must get a card, you must check for the compatibility. You must check to see that it's not available. You must also check for your need, current need, and future need. For instance, I'm getting an input output and I just buy only the USB type. And then in the future, like we already have the HDMI. So if you procure the USB maybe like 3 years ago and now there's HDMI, it means that you're going to remove this one and put another one. But what we're saying in essence is that you need to be sure that the technology also has gone ahead. Then you get the one that has both USB and HDMI, so that you both backward and forward compatible. So these are some of the decisions that you will be making because you are the one that is going to advise the organization on what to do. So this is how you install the adapter card. So you can see the position of the adapter card and then make sure it actually fits into the right slot. That will solve the process. Like I said, I would advise that we go to the lab, watch the videos, try our hands on this, and if you're having challenges still, you get back to me. And let's see, I'll see the best approach to take to solve that problem. So in this lab, you install a NIC, a wireless NIC, and a video adapter card. So this lab for this purpose. If you already have one, fine. If you don't, you should be able to identify the slot and be able to be able to tell us how you can be able to insert it. Same thing for the wireless NIC and for the video. I've showed us the picture of the NIC, the wireless, and that of the video adapter, so that you already know the shape. So when you go to the market, you have an idea of what each of those stands for. So another thing here is additional storage. In as much as we talk about storage, looking at your hard drive, we also have media reader also for storage purposes. So several media card formats have been developed over the years, including securing digital with the SD card that we used already getting used to. And then micro SD, it comes in different shape and size and form factors. Compact flash, memory stick. These are all readers. Even look at your laptop, you also have that provision, where you can slot in the micro SD card. You can slot it in and then be able to copy information into it. So we're saying that you select the right one for your system. And then for external storage, what you're seeing here is pictures of. Hello, what you're seeing here, please mute your mic. What you're seeing here is a typical picture of a flash drive. This is an external storage, so you can actually plug in your flash drive to save more information. Okay, so external USB drive, sometimes called thumb drive, are commonly used as removable external storage. So external storage devices connect to an external port using maybe the USB cable. Some of them use USB cable. Some use eSATA. Some use Thunderbolt ports. I'm talking about Thunderbolt port. We're talking about, like, for instance, your external drive that connects to the head of it is called the Thunderbolt. So you can use the Thunderbolt port in case of it. So you need to know look at the external storage and look at the connector types that will help you be able to achieve that when it comes to storage. So we're looking at everything that is required to interface with the computer in the course of assembly. Video demonstration, so you connect the internal power cables. This video will help us now to connect it. So the good news for us here is that I'm giving you this take-home assignment where you watch all those videos, try to practice on your own before the next class, and then come back to tell me your experience and going to watching the video and then trying to put a computer system by your side and see that everything that you're watching is there. If for any reason you're not seeing the correlation between the physical device and that the video you're watching, you also let me know so that I can reconcile any differences you might observe in the course of doing the assignment. Okay, so it is advised that you watch the video to see how this internal devices are connected. So there's a video also to install the front panel cables. The front panel cables. Those are the cables that goes into the speaker, the ones for the hard drive. The good news here is that it's a live video that show you how these things are plugged. So I advise that we also watch the video so that you know the one that goes for the LED, the one that goes for the hard drive, the one that goes for the speaker. And when you connect those front panel cables to those slots on your motherboard, those drives they start working. I mean, it's a straightforward thing, and it's also written on that cable. So on each of these cables, you see it HDD, you see for power, you see. So those cables are already written. The information is written on them. So it's advisable that you read them, and then even on the motherboard, it's also written so that you'll be able to insert the right cable in the right port. Okay. So you can see what I'm saying here. This is what I was describing. You see here that you have the HD lead, the reset switch, you have the power LED, and then now this is for the positive and this is for negative, and then you have the power switch. Remember your your desktop computer the system will have a toggle switch that you usually press on and off. So for you to press on and for the on button to work, this cable must be connected to the power switch. So you can see here it is written power switch. So you just match the cable to the power switch and then you plug it there. So what we're saying is that each of these is already here for the cables. So it makes it easier for you as an instructor to take this cable and place it in the right pocket. So I advise that we'll do this and then see how that works. Once you put it there, you see everything will match. And then you power on the device. But please be very careful when you're doing this so you don't interchange the cable. So still on the front panel, you have the power button that once you have plugged in those cables to check if it's working, you have the reset button, you have the power LED. All these actually in the front panel, which you can view. You also have the audio cables to test to see if it's working or not. And then you also have the USB to also test if it has been properly inserted or not. So these are also the specifications for it. So when you do this as practical, and then you come back again to go through the material before your assessment, it gives you also another understanding so that you can now have a very good grasp of what we're talking about here. So that cable, when properly plugged, enables all these front panel buttons to start working. And if any of them is not working, it means that you have to go back and check. Okay, so there's a lab here that you need to install the front panel cables to the computer. My advice for us is that as you go to do this assembly on the computer, you can actually, before you unplug those cables, wire the system, because you need to disassemble that and assemble it again. Because you're not going to make any new purchase. So we're trying to see how you can work with existing desktops in your in your lab. So all you need to do now is that you need to identify those cables and then plug them properly to see if it's going to work. So you install the front panel cables in the computer and see so that you can plug and plug and test to see if it's going to work. So complete the computer assembly. So this video helped to finally give us a clear way to complete the assembly of the computer. Like we attach the front panel necessary, plug the power cable into the power supply, which we talked about, orient and connect USB cable to USB port. In other words, position it well, make sure you get the right orientation, and then also orient and connect the video cable to the video port on the video adapter. So tighten the video cable screws to the video adapter, connect the network cable to the Ethernet port, which is also the NIC port, the one I showed us earlier, and then connect the audio cables to the audio port. Select the side panel cover, place the side panel cover onto the case and slide it closed. Like I said, it all depends on the form factor of the computer case. Some computer case you need to slide the cover, you need to be able to close it properly. Some, all you just need to do is to, like, for most of the some of the Dell desktops I've seen, you don't slide the cover in them. You just open it up. There's a button you press, and it opens up, and then you hold down the button and you're able to close it up. So it might not be the case here, but be rest assured that there are features that tells you or give you a guide on how to open up the system, and then when you're done, how to close them up. So you tighten all the screws. Once you tighten all the screws, then you're sure that you're good to go. So you complete the computer assembly. So you say all this you do in the lab. And once you do that in the lab, then you just test to see. But please, before you test, make sure you walk through the process again. Check to see if all those things are properly connected, so that you don't interchange the cable. So you have to be very, very careful with this. And so once you do it right and you power on the system, definitely it will put, as long as the components are working. So that's for assembling the computer system. And I know some of us already have experience with computer system prior to this class. Let's assume if you're doing this for the first time, there's no cost for alarm. We still go back and do practice and then perfect it. Reason being that we have students to go back to and teach. So I would like to entertain questions before I move on. Hello, are we there? Hello?
Yeah, we are there. Yeah, hello.
Yeah, we are there.
Oh, Lord. I'd like so you can actually raise your hand. You can raise it and I call your name, question. Use the raise hand button. Click the hand button. Yeah, so we need to take this practice. Some of us have actually done this. You might have experience to share. So we have that's doubt, right? Tell us all the questions. Domi,
Yeah, the sound breaks from time to time.
Okay, the network breaks. Okay, sorry. Okay, from my end?
I think so.
Oh, really?
And also with the noise. So guys, if you click on the top side on participants, you have a hand that you can raise. So I think the best way is to mute yourself, and so we can speak one-on-one.
Okay.
Raise your hand. So that's right.
Okay.
Thank you. So you raise your hand and one-on-one do your questions and so on. I think it's better to.
Okay.
So we all can hear. Thank you.
Thank you so much. So any question? The 100 raised here. Dowd, can you ask a question? Simon, you have a question?
We cannot hear you. You have to unmute and speak.
Okay, unmute yourself, please, and speak. And if you want me to unmute you, if you have any issue with that, you can also use any of the button or the chat. You can use the chat forum and chat yourself.
Yeah, for today I don't have question.
Oh, no. Okay. So you're good. It means that you can actually assemble the systems, you can identify the components, and the safety procedure, you can adhere to them. And you're sure with the power ratings for each component, you can also be able to identify them as well. And how to take meetings such that you don't.
Yeah.
So who else? If you don't ask questions, I will ask questions. I will call your name and you answer the question. So it means that if you don't ask questions, it shows that you're following up everything, and means I also have the right to ask questions. Med, is that okay by you? So if there are no questions, I will ask questions to be sure that they are with us.
Yeah, it's okay for me.
Okay. So any questions, please? Somebody just gave us a deep sound. So can you ask a question, please?
Yeah, Simon, we see your speaker, but we don't hear your voice. I don't know if you are trying to speak. Oh, no. Okay, so take the chance, guys, to ask questions now.
Okay, I should ask questions. I can see Simon, you unmute yourself. Hello.
Maybe it's a problem with his speaker, his microphone.
Okay, okay. Yakubu?
Yes.
Oh, sorry, somebody said the post. Okay. Okay. Dominic?
Yes.
Yeah, sorry about
Never mind. Yeah, just part of the process. Yes. I was indicating that I actually joined the class much later. But then I realized that at the end of it, I just realized that desktop computer specific. And it doesn't include laptops that used to come with, or some tools that come with the optical desk.
Sorry, I didn't hear you properly. Anybody heard him? It was breaking.
This is what I'm saying.
Okay.
I just noticed that
okay.
The content, the lesson, that's is desktop specific, just desktop computer specific. Right?
Okay.
Yes, and there are also laptops that used to come with, though I don't use one now, I used to come with optical disc. So I want to understand whether just the same formalities apply. Maybe it's universal for both laptops and optical disc as well as desktops with the optical disc.
Okay. If I really get you clearly, you said you could see that the curriculum covers a lot with the desktops, and then if it's applicable to laptops.
Yes, just
yes, the laptop procedure with the desktop, just a slight difference. But you also could see that virtually all the components you have in the desktop, you have them in the laptop. So the procedure for disassembling them or assembling them might not be the same. So for instance, the laptop, sometimes you have to open it up, and then you have to, some of them you have to remove the keyboard first before you begin to access the hard drive. And in some cases, for laptops, you need to turn the laptop and then use a screwdriver to open up the hard drives with the other components. So if you look at it critically, it requires you still opening up the different cases you have in a laptop and still be able to access those components. And of course, the hard drive still looks like a hard drive, though in this case, the form factor. So one unique thing here that differentiates between the two is the form factor. Desktop form factors is different from laptop form factors. So it now has to do with the shape and the sizes. So I think once you're able to get familiarize yourself with the desktop, then going to disassemble or assembly a laptop requires some little logic, and then you'll be good to go. Because most of the components in the laptop, you can actually access them. I mean, like for the screen, for instance, once you're able to remove the cover around it, you can access it. And then for the hard drive, once you're able to use a screwdriver to open up the different screws, I mean, you just see yourself accessing the RAM, the hard drive, the CPU, everything is just get covered up by the case. So in most cases, you see the laptop quite easy for you to open up and diagnose the fault and then reassemble them. So it's a good question you've asked, and I also advise that you also check out the laptops too you have, and then carry out troubleshooting of them. Open them up. I mean, of course, for laptops that you know are faulty, you can learn from there. And that's why I tell my students, I tell them, oh, if you have faulty laptops that you know you're not using them anymore, you can bring them to class. We can use them, and you see them bringing them. They're so sure that has been abandoned, is no longer working. So everybody will open it up and see how they can, and then close it back. I mean, it's fun. So once they practice with that, I mean, when they now face with a working one, they'll be able to know what to do. So the procedures for assembling those laptops are almost the same for most of the laptops. So if they're able to practice with 2, 3, 4 different laptops, I mean, they're good to go immediately. So thank you so much for that contribution.
You're welcome.
Yeah.
May I ask a second question, though?
Yeah, please go ahead.
Yes. I know the business components that we just learned about on the assembly. I think that they are delicate, and I've not heard of healthy or unhealthy ways of keeping them, or just if there are any hazards or factors in relation to the environment or any other thing that may actually get them damaged. I've not heard of that. I don't know whether that one was quite good.
Sorry, I didn't hear you well. You say?
I said good ways of keeping those components, the memory cards, the floppy disks, the hard disk drives, how to keep them, how to ensure that they actually last longer or something. Maybe some hazards that when they are exposed, they get spoiled fast, or ways of keeping them to actually ensure that they last longer.
Yes. In the last class, I don't know if you're in the last class.
I wasn't there though. That's what I said. If that was done fine.
That was discussed in the last class.
Okay, all right. Okay.
Those safety measures.
Okay.
So how you handle them to avoid discharge of ESD, that's electrostatic discharge, you know.
Okay,
ensuring that you wear the strips around to be able to add excess voltage, and then how you carry them, so you don't carry them with your bare hands. You know, you have to wear the normal kits for it. So we discussed all of that as ways to maintain safety, and the safety is for the devices. So all of that was discussed in the last class.
Thank you very much.
I would advise you watch the video again, read the material again. And so that when you're teaching,
I'm not actually on the course, though.
You said?
I'm not actually registered on the course, so I just.
Oh, really? Wow.
Yes.
Are you aware of this?
Pardon?
I know. I'm talking to Marilyn. He
Yeah.
said he's not been registered.
Yeah, he's a coordinator that is trying to help the rest of teachers to join. This is why we have more attendees today.
Okay. So what's your opinion, Marilyn?
About, sorry, he was talking.
But he's requesting to be enrolled to be able to have access to.
I'm not actually sorry. I'm not actually requesting for addition.
Okay.
So maybe
Okay.
you can go ahead with the rest. Yeah, sure.
Okay. Okay. No problem.
Yeah. All right.
So I have some questions from the chat. Please, the front panel. This is coming from Magu Simeon. He said the front panel connectors, are they in the same form in different computers? Yeah, the front panel connectors, they are in the same form in most of the desktop computers. If you look at the pictures I showed us, you see that they come, they actually are quite, there is information written on them, imprinted on them that you can actually plug to the system. So they are actually much alike, maybe some differences, but you can be rest assured that you must actually insert them based on the different slots. So in some cases, it might just be some pins that you need to just maybe 2 pins, 3 pins, 4 pins, and then you have the slot from each of those cables that you just need to plug them. So they are there. You have to watch out for them. If you don't insert those things, then it's difficult to be able to power on the system. It's difficult to be able to see the LED light displaying. It's also difficult to see some of the features actually working. So you watch out for those front panel connectors. Okay. Please, the front panel connector. Okay, I think the same question.
So it depends on the setup that the person who configures the computer wants, right?
You said?
Yeah, I said that the different connectors and the front panel depends on the setup that you want to create, right?
Exactly. You know, like we said, different form factors, computers and all of that. So the position of where you have those front connectors may not actually be the same all the time, but then you could still see it around the motherboard. I mean, still at the front side, but not in the same position. And then actually, some cases with different shape, but then you just have to identify them because they are there. And the good news about it is that you have information written on them to give you a guide. So that guide is always there to direct you.
Is there any standard naming that is used to see if a case and the components are compatible?
If components are compatible with
a case, I mean, is there any standard name that says, okay, if I buy I'm inventing this, an S4, for instance, it will be this standard naming also for the motherboard and so on. Are there standard namings to identify compatible parts?
Yeah, for the compatibility, it has to, because the motherboard comes in different form factors and comes in different, CPU, the motherboard, you could have different cores. So because of the variation in the different shape and size of this, you may not actually have one standard that you could use for all of them. But the point is the protocol that order of operations remain the same. But then for you to say, okay, this is a standard cable that is used across board. And that's the reason why we have this backward compatibility and forward compatibility. So in some systems, you'll be shocked. You won't see an IDE port, but you will see a SATA port for your hard drive. And so the standard is not really there that this is what should be used all the time, but just that the uniqueness behind all this is that they have the same filters share with the modern systems. And so if you say SATA cable remains SATA cable, SATA port remains SATA port. If you say SATA drive remains SATA drive, and must use those cables. So that is like the standard for SATA connectors. And then if you look at the power, also the same thing with SATA cable must go with SATA device. So those standards are applicable based on the components. That if you're using the newest component, then you work with those specifications. But if you're not, and that's the reason why there are extra cables. So in case what you're going to use is not there, you search around and then you pick it up. So you have several cables to serve different purposes. So, but then the standard for each of those components and the right connector that fits to them is there. And then all that matters is that you must get the right device that must go with the right cable at all times before you get it working. If you don't do that, then you have issues. So standards are maintained for drives and their connectors all the time. But then there are options. The options is probably you're looking at a legacy kind of device, and then you're trying to bring it into your computer. There's a provision for that as well, so you can actually go back to use a backward compatibility cable for such purpose. So the system has a way of adapting to both old and new components. But what we're saying here is that for every component on the board, it's a standard connector that must be used to connect it and has to be maintained all the time. So what is required here is that you as the instructor or you as a technician is carrying out the repairs. Once you see a SATA drive, you know you need a SATA cable. Once you see an SSD drive, you know you need to look for the right match of power cable. You don't use a SATA cable to power an SSD drive. So you must identify its own cable to power it up. So those are the standards that have to maintain each time the technician must power any of the components or use any of the connectors to power any of the devices on the motherboard. So you must always look out for that. Like for instance, you have a USB port, you have a HDMI port. The standard unit there is that it's only a HDMI cable that must plug into a HDMI port. It's only a USB cable that must be plugged into a USB port. So those standards remain, and that's the reason why, as technicians, as instructors, you must let your student know that for this kind of drive, you must use a SATA cable. For this kind of maybe if it's an external drive, you must use a Thunderbolt connector. So, and when you tell them this and you show them that standard, they adhere to it. So anytime they have that drive or that external component, they will always search for that standard connector for it. So that is maintained all through. So like I said, except you have an old or legacy component that you're trying to bring in, then you have to look for a backward compatible connector for that purpose.
Mm-hmm. Thank you.
Yeah, thank you. I don't know if that answers your question, addresses your question.
Yes, thank you.
So, like, there's no question today. Then I think some folks are posting in questions here. Please, in case your normal HDD for desktop is damaged, can you fix a laptop HDD and will it be compatible? Okay, the question coming in that you have a normal hard drive for your desktop and it's damaged, and now you have a laptop hard drive, and if you can use the laptop hard drive. If you look at it critically, you want to use a laptop hard drive for your desktop. You need to ask yourself, you need to check to see if the connector, that's the question Mary just asked. the standard here. Because it's a laptop, the cable for it is quite, that's why you call it form factor. It's smaller, so it requires, when you go into the desktop, you could see that it's not really going to be compatible, but it's still SATA to SATA. But because it is designed for smaller drives, and then you're trying to use it for a bigger drive, it's going to be an issue. But then, as long as you have that connector on the desktop that can match with the laptop drive, then it will power it on. But it's so obvious that your HDD for desktop and your HDD for laptop are not actually, because they're not the same form factor, their cable standard will not be the same. So the pin configuration also, there will be that variation. So those are things you have to look at for. But then the thing you can do here is that you can make it compatible. You can use it by actually putting it in a case and using probably USB or a Thunderbolt and connect it to the desktop and allow it to boot. That means when you're doing your boot up, you say, okay, boot from an external drive. So at that point in time, that hard drive of yours from your laptop will be used as an external drive on the desktop. And then you can load up, if you want to call up your operating system, you can call up your operating system from that particular drive. That will work. That will work because now you have converted the whole process by trying to use it as USB, or you're trying to use it as Thunderbolt connector to connect it to your system. So if you do that, then you can actually now select the boot process that let it boot from that particular drive, and it's going to work. It's going to work. I've tried that before and it works. So that will solve the problem if you want to do that. Okay. Yeah. So I can see. I hope we heard me too clearly. It's being recorded, so I'll make the recording available today.
Okay. On Saturday, I'm not sure that I will be able to join. I will try to join from the mobile and see if we can record, like if I can still open the recording. But otherwise, I will forward anyway the link so the rest of the teachers can connect.
Okay. No problem. And I have activated the assessment, so I think I would advise to start reading and trying to attempt them.
So now the teachers can watch the recording if they couldn't attend the class for chapter 1 and chapter 2, and then follow the chapter 1 and 2 in the MetaCAD course. And do the assessment for both chapters, right?
Exactly. Sure. They can watch it and take the assessment.
Perfect. So teachers, better to follow chapter 1 and 2 in MetaCAD as soon as possible and do the assessments so you don't accumulate too many for later.
Okay.
Thank you, gentlemen. I can see they are all gentlemen. There's no ladies among them. Marion.
Not yet. Not yet.
You said?
I said not yet.
Okay, no problem. Is it a male institution?
No, not really. But this group of teachers in particular, they are males.
Okay.
But no, it's not a...
Don't mind my question. I'm only trying to observe something. So thank you all for attending the class. I just will take it one chapter at a time and see how we go from there. If we're able to do very well and assimilate better, then subsequent classes might take maybe 2 chapters.
Thank you too.
What we want is for you to go through the recording over and over, read through the curriculum, make sure you perfect it very well, and then go to the lab, watch the videos, practice it, and then you can come back in the next class and have questions again. I could take the first 5-10 minutes to answer questions, and then we'll move on from there. Okay, so do have a lovely night.
Thank you.
Thank you.
Thank you very much.
Yeah, bye everyone.
See you in the
Bye. Thank you.
Bye.
Bye.